Under Geneva's cloak, on the surface of the Earth, lies a human marvel, a symbol of resiliency and potential, and a sign of impending doom for some, the Large Hadron Collider, LHC. This machine is an unusual instrument for researchers, enabling them to investigate subatomic particles and discover what some call God's secrets. The particle known as the Higgs boson is central to this pursuit. Renowned physicist Brian Cox recently made a terrifying statement that has caused a stir, even among the religious community, claiming that a significant event has been discovered at CERN, with implications far beyond what we currently comprehend. Before delving into the repercussions of Cox's assertion, it's essential to understand how the Large Hadron Collider, LHC, works. Operated by CERN, the LHC is a 17-mile ring of superconducting magnets, the most powerful particle accelerator in existence. It stands as a zenith of human achievement, capable of replicating the conditions of the universe's creation. This titanic design allows us to discover the mysteries of the cosmos. CERN, established in 1954, is one of the most renowned research institutions, consisting of 23 member states. While the LHC is the centerpiece of its efforts, it is only part of an extensive network of accelerators and detectors used to study the subatomic world. Inside the LHC, protons are accelerated to near the speed of light to recreate the energy conditions immediately following the Big Bang, temperatures millions of times hotter than the core of the Sun. A complex system of magnets directs the protons through the collider, while advanced cooling techniques maintain temperatures even colder than outer space, which is crucial for the use of superconducting magnets. Collisions occur at 4 points along the accelerator, corresponding to the 4 main particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors record the effects of the collisions, allowing researchers to sift through the debris in search of elusive particles like the Higgs boson, a particle that holds the key to our understanding of the universe's structure. The LHC is not only a scientific instrument but a testament to human imagination and aspiration. It represents our quest for knowledge and our eagerness to comprehend the fundamental forces shaping our universe. However, testing the limits of understanding also requires confronting moral and existential questions. What are the risks associated with exploring the unknown? Could our search for knowledge accidentally unleash forces beyond our control? Within the hallowed halls of CERN, where the frontiers of human knowledge are constantly expanding, a revelation has emerged, one that has sent shivers down the spines of even the most experienced scientists. Brian Cox, former CERN researcher and respected voice in particle physics, recently made a statement that amazed and terrified the scientific community. The goal of CERN's LHC is to create a scaled-down version of the Big Bang, the event that birthed our universe. Cox emphasized the potential outcomes of this objective, including the possibility of revealing new phenomena, studying dark matter, and deepening our understanding of the Higgs boson. The idea of recreating a mini Big Bang is not just theoretical. Within the LHC, it's a tangible reality. The collider's conditions mimic those present at the universe's inception, allowing scientists to observe the very birth of existence. However, with this kind of power comes great risk and responsibility. Consider the 1978 incident in Russia, where physicist Anatoly Bugorsky accidentally intersected with a proton beam at the Institute for High-Energy Physics. Despite severe injuries, he survived, a testament to the immense power and potential danger of particle accelerators. One of the most significant fears surrounding the LHC's experiments is the possibility of creating miniature black holes, regions of spacetime with such intense gravitational pull that not even light can escape. If such an entity were created, even on a small scale, it could theoretically pose a threat to Earth. However, CERN scientists have assured the public that any black holes created would evaporate almost instantly. Understanding how the LHC could create a black hole involves the fundamental mechanics of particle acceleration. When protons are smashed together at near-light speeds, the energy is so intense it could warp spacetime itself. Picture spacetime as a tightly stretched trampoline. A heavy object dropped on it creates a warp. If the object were heavy enough, it could theoretically create a tear. Even the late physicist Stephen Hawking expressed concerns. He warned that the Higgs boson could become unstable at extremely high energy levels, potentially causing a catastrophic vacuum decay, an event that could destroy the universe. Respected cosmologist Sir Martin Rees also voiced similar concerns in his book Our Final Century, highlighting the unpredictable nature of particle collider research and the possibility of triggering a catastrophic phase transition in spacetime. While these outcomes are hypothetical, the seriousness of even the smallest risk demands careful consideration. With such high stakes and razor-thin margins for error, CERN experts have implemented numerous safety protocols to minimize any potential dangers. Yet, scientific exploration always involves a degree of uncertainty. The pursuit of knowledge requires taking risks, and it is this boldness that has propelled humanity forward. The LHC represents the culmination of decades of scientific advancement and international collaboration. Beneath its awe-inspiring design lies a realm of profound scientific inquiry, one filled with both incredible potential and ethical dilemmas. The collider's primary goal is to unlock the mysteries of particle physics, leading to groundbreaking discoveries such as the Higgs boson. But the enormous energies involved also raise questions about possible catastrophic consequences. Despite rigorous safety measures, the possibility of creating black holes or other anomalies cannot be entirely dismissed. As researchers continue to push the boundaries of understanding, it's vital to approach these investigations with transparency, responsibility, and a commitment to global discourse. The LHC is a marvel of modern engineering and a focal point of contemporary physics and cosmology. Its purpose is to investigate the basic particles that make up the universe. Its existence allows scientists to recreate conditions immediately following the Big Bang, offering a unique opportunity to study the Higgs boson and other fundamental particles. The Higgs boson, sometimes called the God particle, was proposed in 1964 by Peter Higgs and others as a crucial part of the Standard Model, which describes the fundamental forces and particles that constitute our universe. The LHC's discovery of the Higgs boson marks one of humanity's greatest scientific milestones. The discovery of the Higgs boson in 2012 was a monumental achievement, confirming a key component of the Standard Model and validating decades of theoretical physics. It proved that the Higgs field, an invisible energy field that exists throughout the universe, gives mass to elementary particles. Without it, matter as we know it wouldn't exist. Yet, despite this triumph, the discovery also opened the door to even deeper mysteries. What lies beyond the Standard Model? What explains dark matter, dark energy, and the imbalance between matter and antimatter? These are the profound questions that now guide CERN's mission and drive the continued use of the LHC. Dark matter, for instance, is believed to make up about 27% of the universe, yet it remains undetectable by traditional means. The LHC provides a unique environment where scientists can attempt to create and study dark matter particles under controlled conditions. If successful, this could revolutionize our understanding of the cosmos and unlock new realms of physics. However, as the quest for knowledge grows more ambitious, so too does the concern. Some physicists worry that by pushing the boundaries of what is physically possible, we risk crossing into unknown territory, where the laws of nature might behave unpredictably. Could a collision create a stable black hole? Could we unwittingly alter the fabric of space-time? Could vacuum decay, once a distant theoretical possibility, become reality? Although these scenarios are considered extraordinarily unlikely by the scientific consensus, they cannot be entirely dismissed. It's this fine line between brilliance and danger that makes the work at CERN both exhilarating and sobering. Public engagement, therefore, becomes essential. The scientific community must not only conduct its research with diligence and care but also communicate openly with the world. People have a right to understand what is being done beneath the surface of Geneva, to grasp not only the scientific potential, but the philosophical and existential stakes as well. Ultimately, the LHC is more than a machine. It is a symbol. A monument to human ambition, to curiosity, and to the relentless drive to understand our place in the universe. As we continue to delve deeper into the building blocks of reality, we must walk this path with wisdom, guided not only by intellect, but by humility. The future of particle physics lies not only in the discoveries we make, but in how we make them, responsibly, transparently, and with full awareness of their implications for the world. In 2012, it was established that the Higgs field, an invisible field that gives mass to other particles, was a significant discovery. This accomplishment validated decades of theoretical work and enhanced our understanding of the universe's fundamental structure. On the other hand, like with all important scientific endeavors, the pursuit of knowledge at the LHC has both immense potential and associated dangers and ethical dilemmas. The energies involved in collisions between particles are enormous. While the potential of the LHC includes generating new materials or unexpected reactions, such outcomes cannot be completely ignored. Some researchers have envisioned scenarios in which collisions of high energy could result in tiny black holes or other bizarre substances that raise questions about the potential consequences of such events. While most scientists consider these risks to be extremely remote, the nature of scientific inquiry necessitates venturing into the unknown. Brian Cox's assertion that it's possible to replicate a miniature Big Bang in the LHC highlights both the profound significance and potential dangers of this study. The Large Hadron Collider represents the pinnacle of modern scientific endeavors. However, its extraordinary capabilities also invite critical discussion about the restrictions and responsibilities of science. The goal of both the design and operation of the collider is to investigate fundamental questions about the universe. Nonetheless, it operates at the frontier of human technological capability and knowledge. This intersection brings up significant questions about the nature of science and the ethical ramifications of risk in such cutting-edge research. One of the most exciting features of the LHC is its ability to precisely recreate the conditions that existed minutes after the Big Bang, a fascinating look at the universe's beginning. By simulating these early moments, scientists can investigate particles that existed in the primordial universe and examine phenomena that would otherwise be impossible to access. By replicating these extreme conditions, researchers are able to test hypotheses and fine-tune models in particle physics. For example, the LHC experiments have the potential to explore the properties of hypothetical dark matter particles, particles believed to make up a significant portion of the universe's mass, but which remain hidden from conventional detection methods. The investigation into dark matter is driven by its profound effects on our current understanding of the universe. Dark matter is inferred from its gravitational effects on visible matter, however, direct detection remains elusive. The LHC addresses this challenge by attempting to create dark matter particles in the lab. If successful, this could revolutionize our understanding of the universe and lead to new discoveries and insights. The LHC also functions as a powerful tool for studying one of the four fundamental natural forces, the strong force, which binds protons and neutrons within the nucleus of an atom. Understanding its high-energy performance can provide insights into the fundamental elements of matter's structure. The LHC's ability to investigate powerful forces at unprecedented scales allows researchers to study the interactions between quarks and gluons, the elementary particles that mediate the strong force. The results of these investigations could lead to greater comprehension of nuclear physics and the behavior of atomic nuclei. Moreover, the technological advancements driven by the LHC extend beyond particle physics. The collider's complex systems for analyzing and detecting particles have sparked innovations in data analysis, computer science, and sensor technology. For instance, the development of the World Wide Web was originally designed as a way for scientists to share data from particle physics experiments at CERN. Today, that technology has transformed global information sharing and communication. The advancements in computing and data management required for the LHC have had cascading effects across various fields, demonstrating how research-driven technology can influence broader society. However, operating such a powerful scientific instrument requires strict safety regulations and ethical oversight. The potential for unexpected outcomes, such as the creation of exotic or unknown particles, necessitates careful risk assessment. While theoretical models suggest that catastrophic events are highly unlikely, the possibility cannot be entirely dismissed. Due to this uncertainty, researchers must approach their work with caution and transparency, ensuring that safety protocols are robust and that the public is informed of potential risks and the measures taken to mitigate them. Public understanding and engagement are crucial, especially for scientific projects with the potential to impact society at large. The LHC has inspired significant discussion and interest, highlighting the importance of communicating complex scientific concepts to broader audiences. Effective science communication helps demystify research, encouraging informed public dialogue about both the potential and risks of advanced experiments. By maintaining open communication with the public, scientists can address concerns, dispel misconceptions, and build trust in the scientific process. As we continue to advance the LHC's operations and explore the possibility of new findings, we face important questions about the future of science. Exploring previously unknown regions of particle physics may raise new challenges that push the limits of human knowledge. Advancing these frontiers will require collaboration among scientists, engineers, and policymakers to ensure that research is conducted ethically, and that the benefits of scientific progress are maximized while minimizing potential risks. The LHC stands as a symbol of human ingenuity and our insatiable thirst for knowledge. It represents the merging of cutting-edge technology, theoretical physics, and international cooperation, a collective effort to uncover the deepest secrets of the universe. As we continue to explore the fundamental forces and elements that make up our world, vigilance regarding the ethical implications and possible consequences of our research is crucial. In conclusion, the Large Hadron Collider remains at the forefront of scientific inquiry, offering novel insights into the universe's nature. Its experiments have the potential to open new domains of knowledge, drive technological innovation, and reshape our understanding of existence. Yet, with its extraordinary capabilities come significant responsibilities. The pursuit of knowledge must be balanced with a commitment to safety, transparency, and public engagement. As researchers continue to investigate the outer limits of particle physics, the LHC will remain a testament to human curiosity and our quest to unravel the fundamental mysteries of existence. Beyond its role in advancing particle physics, the Large Hadron Collider, LHC, exemplifies the broader societal impact of scientific infrastructure. The international collaboration behind the LHC, bringing together thousands of scientists, engineers, and institutions from around the globe, serves as a model for how shared scientific goals can transcend borders and politics. It demonstrates that, when united by a common purpose, humanity can overcome differences to explore questions that concern us all. The collaborative spirit nurtured at CERN has not only yielded scientific breakthroughs but also fostered a culture of open data, shared knowledge, and global scientific literacy. These principles are essential in a world where misinformation can spread rapidly and public trust in science must be continually earned. Furthermore, the LHC inspires the next generation of scientists, innovators, and thinkers. Its discoveries and the stories behind them are incorporated into education, sparking curiosity in students and encouraging them to ask bold questions. Educational outreach programs, virtual tours, and online platforms bring the excitement of the LHC into classrooms and homes, ensuring that the benefits of this endeavor reach far beyond academia. Yet, as the LHC continues its exploration of the subatomic world, it also invites reflection on what it means to explore. Scientific progress often requires venturing into realms that challenge our current understanding, and in doing so, we must remain mindful of the limits of our knowledge and the responsibilities that come with it. As the collider probes deeper into the quantum universe, new mysteries are likely to emerge, mysteries that will demand not only technical innovation but also philosophical and ethical contemplation. Looking ahead, future upgrades to the LHC and proposals for even more powerful colliders open the door to potentially revolutionary discoveries. Concepts such as supersymmetry, extra dimensions, and the unification of fundamental forces are not just abstract theories, they are testable hypotheses that may soon be within reach. These ideas could radically shift our perception of reality, redefining space, time, and matter. But with each advance comes a new wave of questions. What are the implications of discovering phenomena that challenge the standard model? How will such findings influence technology, security, or even our understanding of consciousness and life itself? These questions highlight the dual nature of scientific power. It enlightens, but it also compels us to act with foresight and humility. The LHC's legacy, therefore, is not just written in data or particles, it is etched in our collective journey as a civilization reaching toward the unknown. It stands as a monument to imagination, cooperation, and the enduring belief that the universe, in all its vast complexity, can be understood.